Today we are going to study chapter 9, which is the last chapter covered in this semester. Okay. The topic of this chapter is structures, enumerated types, and dictionaries. Okay. These are the three things we are going to cover in this chapter. In this chapter, we are going to learn three different concepts: structures. Structures will allow you to encapsulate several variables into a single item. In chapter 10, we have learned how to define a new class. As I mentioned in that chapter, so a new class can be considered as a blueprint. Okay. So in such a class, a lot of things can be defined. Okay. But a structure is a simple way for this blueprint. Okay, simple way for this blueprint. So basically, a structure can allow us to capture several variables. You can see that here we are focusing on variables into a single item. Okay, in a single item, for example. So we still want to use a car example. If we want to have a car, right? Blueprint, and we only have like two variables. One is mileage, another one is like a brand. For example, we only have the two variables. So in this case, using a class may be too complicated. We can use a structure. Okay, so to include these two variables for a car. The second concept is enumerated types. These which are data types that you can create. Okay. So, for example, we want to consider 7 days in a week: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Right? We want to consider all the days in a week. So, in this case, we can use enumerated types. The third concept is dictionary. So, dictionaries, which are data structures to storing items known as key value pairs. Okay, it's like for dictionaries, we have two things. The first one is key. The second one is value. Like you have ID and a value for each element. Okay, we are going to learn these three different concepts. The first concept is structures. So basically, you can group several variables together into a single item known as structure. It allows you to create custom data types for your programs. Each variable in a structure is known as a field. Fields in a structure can be of different data types. Okay, so the general form to declare a structure in C# is, so the keyword here is we use struct. You can see that struct, that keyword blue, right? So it means that it is a reserved keyword in C#. Okay, we use struct keyword. Then we have struct name. Similarly, struct name will follow Pascal case. Each word will start with a capital letter. So inside this pair of curly braces, so we will have public field declarations. Okay, you see that here we only consider field. It means that in a structure, we will only consider field. This is the difference between the structure and a class. In a class, we can declare both field and methods. Okay, we can declare both fields and methods. But in a structure, we can only consider field. Another thing is here we need to use public, okay, because the field for each structure has to be accessed by other different classes. So where struct is a keyword, public is the access modifier. Okay, this is a format for how we declare a structure. So actually, structure is a very useful, okay, data type in data analytics. Why? Because sometimes you do want, for example, I want to analyze some data information from a batch or the sales of the car, right? So in this case, each car will have a couple of attributes which we are interested in. And we want to analyze all these different attributes. It means that not just only one attribute will be analyzed, all several attributes associated to a car will be analyzed. So in this case, you can use structure to group these attributes for each car, then load the whole data set. Okay, load the whole data set. Another example is sometimes you may need to solve a problem. Okay, you need to load information from data and solve a problem. So the problem will have different components. Okay, different components. So all these components are required for this single problem. Okay, and you have multiple problems, multiple instances of this problem. In this case, you do want to use structure to define each individual problem, because for each problem it can have multiple different variables field, and we need to have multiple problems. Okay, so in this case, so using structure is an efficient way, okay, to define different problems. So at first, how we can declare a structure? So you can declare a structure outside the application's namespace or inside the application's namespace, inside a class, inside another structure. Okay, you can declare a structure in a very flexible way. So for example, how we create a structure. So in this example, used car dealers application need these variables. First, okay, for such a car, so first we need a make. Okay, we need a make, and which is a string variable. Second variable is int. Okay, which is the year. Okay, for example, 2017. So the third field is a mileage, which is not whole number. Which is, in this case, we use a double variable. So we have three different fields: make, which is a string variable; year, which is an int variable; and mileage, which is a double variable. Okay. So with these three components, so you can organize them into a structure as follows. So we use the keyword struct struct. And the name of the structure is automobile. You see that in this case. So automobile is in what? Is in Pascal case, right? The word automobiles will start with capital A. So inside the structure, inside this pair of curly braces, so we can have three different fields. Okay, public, string make, public, int year, public, double, and mileage. Okay, so if this is the structure in your project, okay, you can write some simple comments to describe what is this structure. Okay, so you then create one or more objects of the structure. Here we have declared the blueprint for the automobile. Okay, it means that in the future, if we declare an object of this structure, that object itself will have three different fields, such as make, year, and mileage. Okay, make, year, and mileage. So this is the format how we can create one or more objects of this structure. For example, if we just want to create one, you can do automobile, sports car, new automobile with a pair of parentheses, semicolon. In this case, sports car is an object which will fit the blueprint automobile. Okay, it means for sports car, you will have three different properties, three different fields: make, year, and mileage. Okay. So another example is automobile pickup truck. In this case, we also declare an instance or object of the structure pickup truck. Okay. So after the declaration, the pickup truck will also fit the blueprint automobile. It has three different fields: make, year, and mileage. Okay. So this is how we declare such a structure. Okay, such a structure. So here is one example. So create a structure student with string variable UID, int variable year, and double variable GPA. Okay. So in this case, we need use struct student. Remember, add this student will follow Pascal case. We have a pair of curly braces. Inside this pair of curly braces, we have three different fields: string, public string UID, public int year, public double GPA. Here, you need to use both the access modifier, public, and the type keyword for the variable, like string for UID, int for year, double for GPA. Okay, double for GPA. So this is the one simple example. So it means that in the exam, if I ask you to create a similar structure, for example, I've asked to create a structure car with three different other properties, you should be able to use this kind of definition, right, to declare a structure, So how we can access structures fields? So you can access a structures fields using the dot operator to assign value to or retrieve values from fields. Okay, retrieve value from fields. Remember in C, when we learned the concept, class concept. So when we want to read or write a field, right, for a class, so we use get and set. Okay, we need to use get and set keyword to declare a field is read only, or it can be read or can be written, right? So here, because for structure, we are only dealing with fields, no methods. Okay, so we have structures and we deal with fields. So here we don't need get and set. Instead, all the properties, or in other words, all the fields associated with a structure object can be used to we can assign values to it or retrieve values from it. For example, here, automobile sports car equals new automobile and a pair of parentheses semicolon. Okay, so sports car make, here we can set its value equal to Ford Mustang, and sports car year equals 1975. And sports car mileage, here the format is we have a dot. Before the dot is will be the name of the object, of the structure object. After the dot will be the name of the field. Okay, we have sports car. Sports car is an object of the automobile structure. Make is its field. Okay, make is field. Sports car dot make equals Ford Mustang. Sports car dot year equals 1964-5. Sports car dot mileage equals 67,500.0. Okay. So to retrieve values from the field, okay, you can see that you can got sports car dot make, because make is we have declared make is a string variable. Make a string variable. So we can use the sports car dot make as directly as the input of the message box dot show method. Okay, because message box dot show method requires a string input. Similarly, for year, this is a int variable, so we have to use the toString method. You can see there are two dots, right? The two dots here. Okay, for the sports car dot year dot toString, the first dot is used to access the field of the structure. Okay, the second dot is used to access a method associated with a variable. Okay, we have two dots. Okay, so for the mileage, it is a double variable, so we still have two different dots. The first dot is to access the structure field. The second dot is to access the toString method. Okay, so you can, another thing I want to mention here is, so when you want to access assign values to these fields or retrieve values from the fields, you need to be careful about the type of those fields. For example, if UID is a string, it is a string. If you want to set up assign value to your UID property, you need to remember it's a string variable and we need double quote, right, for string variable. So year is a int variable. In other words, if you want set up, you cannot use a decimal number. You have to use a int number. Similarly, GPA is a double variable. So when you set up, you can use a double type, right? A int number is also okay because double variable can be consistent, can be compatible, right, with int numbers. But if here you write 67500.0m, then that is an error because double variable cannot be compatible with decimal numbers. Okay, so in other words, when you want to use these properties of a structure, you need to be careful about the data types, the types of these variables. Okay, so you can assign one structure object to another, use the assignment equal operator. In this case, the whole structure sports car can be considered as a whole object, single object. If car number 2, right, car 2 is also object of the automobile structure, you can use the equal sign, right, to assign the sports car value to car 2, right? In other words, if sports car make equals Ford Mustang, sports car dot year equals 1965, sports car dot mileage equals 6750.0. So if we do this equal sign, okay, then car 2 you will have the value dot make is Ford Mustang dot year equals 1965. Car 2 dot mileage equals 67500.0. Okay, for car 2 the structure in object, all its field values will be will copy, right, the values from the object sports car. Okay, copy from sports car. So here is one example. Assume that we have created a structure student with string variable UID, int variable year, and double variable GPA as follows. Struct student. So public, we have string UID, public int year, public double GPA. Declare a student instance, BARS student, as assign its UID equals 1, 2, 3, 4, 5, 6, 7, 8, year equals 2017, GPA equals 3.5, or GPA equals 3.5. So this is the answer. First, we need to declare an object, right? A new object of the structure, and the name is given, which is BARS student. Okay, we declare student, an instance or an object of the student structures, BARS student. Then we assign the values to its 3 different properties. The UID equals double quote 1, 2, 3, 4, 5, 6, 7, 8. Year equals 2017. GPA equals 3.5. Or GPA equals 3.5. So arrays of structure objects. So in this case, you can treat each structure object as a single element, Then we can declare array of structure object. It means first we declare array. For each element of this array, each element will be a structure object. Okay, let's see one example. So structure objects can be stored in an array. So here is one example. First, we declare constant. Remember, usually when we want to declare an array, so we want to use a constant, okay? Constant, because if in the future we want to change the number of elements in an array, we can just change the definition of this constant, okay? Anything else will be the same, okay? Anything else will be the same. So automobile, first we have this pair of brackets, okay? We have cars equals new automobile. We have a size parameter here. So this is consistent with the format. how we declare an array, right? For example, if you replace this automobile with int, right? Automobile with int. Then this is the exact format for us for how we declare a int array. Okay, int array. So here, because we have declared automobile structure, so we use automobile here. In other words, we declare cars, which is an array of automobile structure objects. Okay, so to access one object in an array, use the subscript. You see here, if we declare, so there are 5 elements, right? Size equals 5. We declare array with 5 elements, and each element is an automobile structure object. If we do cars number 2 dot mileage, so index number 2 will refer to the third element. Okay, to the third element. In other words, by using this kind of cars 2 dot mileage, we are accessing the mileage field of the third element, right? Third element will have index number 2. The mileage field of the third element in the array cars, So because we have array, we can also create loops to access the array. Okay, index is 0. Index is less than cars length. You see here, cars is array of structure objects. So when we use its length property, we are trying to see how many elements, right, are in this array, index plus plus. So we have cars dot index dot year. So dot year is we want to access the year property of this element, of each element equals 2016. To store a structure object in a list, we can do for each. We can have car list, right? Car list dot add a car dot make. Okay. So here is one example. Assume we have created an array of student instances as follows. We have declared constant size equals 4. Then we follow the format to declare array of student array objects, be as students. Write a for loop to assign 2018 to the year variable of all instances. Okay, here we have a for loop. This loop is almost the same as this example. Okay, as this example. So we have the for loop int index is 0, index is less than length property index plus plus. So for each element, we access its year property and assign its value to equal to 2016. Because here year is a int variable, so we just use a number. Okay. If you are accessing a string variable and you want a assign its value, you need to use double quote for string variable. Okay, be careful about it. So the date time and time span structures, okay? So the date time and time span structures are useful structures which are already built in .NET framework. It means that so we don't need to write these 2 different structures, okay? The structure date time and time span have been declared in .NET or in Visual C#, okay, already. So here in this topic, we are going to learn how we can use these 2 different structures, okay, 2 different structures. So in the .NET framework, the date time structure stores a date, a time, or both, okay, date or time or both. It depends. The parameter you can, the arguments you use for this datetime structure. In the .NET framework, the time span structure stores information about a time interval. Okay, a structure stores information about a time interval. So why we are interested in that? Okay, because sometimes when you build your application, right? At first, you do want to get a grab the time information from the system, because you have no idea when the user will use application, so you do want the application can extract or can grab the information, the up-to-date time information from the system. For example, if I open application, so your application has to be able to figure out, right? The current time is 3:56 p.m. or the date is November 30th, 2020. Okay, application has to be able to figure that out. Okay, that is date and time. So another structure is time span. Okay, sometimes so we are interested in the active time, duration of the application. For example, when we start, okay, the application, and until the user closes the application. So what will be the time duration of this session? Okay, that is one thing we are interested in. Sometimes if your application requires some computational work, so you may want to report the computational time of the analysis to the user. Okay, for example, if you have application to analyze a data set, okay, and the user is using your application to load a data set for the analysis. Okay, so after some time, your application provides the output, or provides the output. So in this case, you want to report also how much time. So how much time has been used to get the output? Okay, so that can be a useful metric for your algorithm. Okay, useful metric for the algorithm. So in this case, the time span is a useful structure to use. Okay, time span is a useful to use. Okay, useful structure to use. And first, let's see the date time structure. Okay, so the date and time values are stored internally as first. We have month, which is an integer in the range 1 to 12. Day, an integer in the range 1 to 31. Year, it's an integer in the range of 1 to 9999. Okay. Hour is an integer in the range of 0 to 23. Minutes, integer in the range 0 to 59. Second, an integer in the range 0 to 59. Millisecond, an integer in the range of 0 to 99. Okay. So it means that in the C# or in the .NET framework, so these properties, year, month, day, hour, minute, second, millisecond, these 7 different properties, okay, have been built in Visual C# or .NET framework already. So we can just use the 7 attributes or some of attributes, okay, without declaring any of the attributes. So here is the following creates an instance of the datetime structure named dt. Set the default date of January 1, 0001, 12:00 a.m. 0 milliseconds. Okay, milliseconds. First, you declare an object of datetime. Remember, this datetime structure has been built in Visual C#. It's already, okay? So we do not need to redeclare it again. It's already there, okay? We just follow the format, how we can declare a new object of structure with datetime, dt equals new datetime, which is the name of the structure, a pair of curly braces, a pair of parentheses, then semicolon. So to change individual date and time properties, so we can do dt.month is 12, d.day is 15, d.year is 2019, d.hour is 13, d.minute equals 30, d.second is 0, d.millisecond is also 0. Okay, so by assigning all the values of the 7 different fields, year, month, day, hour, minute, second, millisecond, these 7 different properties, dt is set to December 15, 2019 at 1:30 p.m. Okay, 1:30 p.m. Okay. So this is the date-time structure. Date-time structure. So let's see further things for date-time structure. So to display the current date and time, you can do datetime, current datetime equals datetime.now. You see here, right? Here, you use the now property of date and time. This is, you can do what? Basically, you can get the current property, the current date and time of from your computer, from your system, right? From a system. So to convert a string to a datetime structure, so we can do this, okay? We can do datetime.tryparse string output, okay? Output out target variables. Okay, we can convert a string to a datetime structure. So what is that? Okay, it is this. Okay, it is this. Let's see. Okay. So if you search, right? If you search date and time, right? I just search over on the internet. Okay, I search on the internet. You see, this is the document I searched. Okay, I searched from the Microsoft website. Okay, for Visual C#. So you see, it's a very long document, but you can browse it quickly. Okay. For example, to set date and time, at first you can provide some arguments, right? In this case, so you can get date and time will be 2008 May 1st. It is 8:30 and millisecond is 52. Okay. Oh no, 8:30 minutes and 52 seconds. Okay, date time. So and also, okay, so you can use datetime now to get the current time. Okay, current time. So you can also to get a string, right? To string that represent a data. It means that if a string equals a time is a time format, right? Is a time format, you can convert a string to a datetime structure. Okay. So in the slides or in the textbook, okay, some concepts are not introduced with all the details. In this case, you can go to online documents and try to read the documents briefly. Okay, I understand. So it will be difficult or it will be challenging to read the full document, but try to read a part of the document that is doable. That is doable. So for date and time objects, we can compare date time objects using relational operators. For example, if we have we use the greater sign. Okay, object one is a date time object. Object 2 is another date time object. If we use object 1 is greater than object 2, so that expression, okay, that expression will be true if object 1 is later than object 2. In other words, object 1 is more than object 2. It means so object 1 is later or object 2 is earlier, right, than object 1. Okay, object 1. So if we do object 1 is less than object 2, it means the expression is true if object 1 is before or earlier than object 2. Okay, and so on. Okay, so if in your code, right, if you have two datetime objects, you can use greater than or less than these relational operators to compare its values. Even though they are not exactly numeric values, but in this case, because it's a time, right? It's a time, the greater or less than those signs have some meaning. The meaning is, so if we use greater sign, it means object 1 is later than object 2. If we use object 1 is less than object 2, we want to, we mean that object 1 is earlier, right, than object 2, okay? Object 2. So with this kind of explanation, you should understand, one, we can use these relational operators. One can use these relational operators. Another useful structure is time span structure. So time span structures allow you to create objects that store data about an amount of time, such as 9 days or 12 hours, using the following properties. Okay, so for this, for the time span structure, we have property days. Okay, it's an integer. It's positive or negative. Hours, it's an integer in the range of minus 23 through 23. Minutes, an integer in the range of minus 59 through 59. Seconds are an integer in the range of minus 59 to 59. Milliseconds, an integer in the range of minus 99 to through 99. Okay, so we can create an instance of the time span structure named TS span. The format is similar as the previous one, how we create a structure object. Time span, the name of the structure. TS span, T span is the name of the object. New is the keyword. Time span is the name of the structure with a pair of parentheses, semicolon, okay, plus semicolon. Okay, we create an instance of the time span structure named T span. So to change individual date and time properties, we can use first declare an object, time span object, T span. T span days is 15, T span hours equals 6. T span minutes equals 30, T span seconds equals 10, T span milliseconds equals 500. So now, when we when we execute all the 1, 2, 3, 4, 5, 6, right, 6 lines of statements, the T span object, okay, is set to 15 days, 6 hours, 30 minutes, 10 seconds, and 500 milliseconds. Okay, 500 milliseconds. Okay, the time span is basically used to what? To record, right? How long is the duration of some session? For example, the session of the application, or the duration of the running of an algorithm. Okay, it can be used to record the time span. So performing math with date time and time span objects. So because even though date time and time span are a structure, they are actual time, right? We can do what? We can add or subtract a time span object to or from a date time object to get another date time object. What is that? So it is like this. It is like, for example, so we know that the session will start at 2 p.m. Okay, and we also know that the time span of the session is 15 minutes. Okay, the question is, what will be the ending time of the session? So we can use a simple math: 2 p.m. plus 15 minutes, which is 2:15 p.m. Okay, this is we have date time 2 p.m. plus a time span 15 minutes. We get another date time, which is 2:15 p.m. So another example is, so we know that the session ends at 2:15 p.m. We also know that the time span is 15 minutes. So we are interested in when the session started. So in this case, we know the ending time 2:15. We know the time span 15 minutes. So starting time will be 2:15 p.m. minus 15 minutes, which is 2 p.m. Okay. Because the key point here is the date time and time span are actual time. Okay. So because of that meaning, we can do addition or subtraction. So here is one example. Create and add a time span object that represents 10 days to a date time object. Okay. First, we declare a date time, which is date time, the name of the object, structure, dt, the name of the object, right? And we have 3 inputs, which is 2019, 8, and 15. In other words, date time equals 2019, August 15th. Okay, August 15th, 2019. Then we can create a time object time span, name of the structure, t span, name of the object. We have also have 4 different parameters: 10 hours, 0 minute, 0 second, 0 millisecond, right? It is 10 hours, okay? So we can add the time span object to the datetime object. We have dt, which is time datetime, plus t span, which is time span. It is 2019 8:15, right? Plus 10 hours, okay? Plus 10 hours. So it will be what? 8:15 will be the morning, plus 10 hours will be 6, right? 6:15 p.m. Okay, sorry, it's August 15th, okay, plus 10 days. It is August 25th, okay, we are still dealing with date without time, okay. We have 2019, which is a year, August 15th plus 10 days, which is August 25th, okay, 2025th. So we have finished, okay, date time structure and time span structure. Now we move on to the next topic, which is enumerated types. Okay, enumerated types. An enumerated type is a programmer-defined data type. It contains of predefined constants known as enumerators. Enumerators represent integer values. When you create an enumerated data type, you specify a set of symbolic values that belong to the data type. An enumerated data type declaration begins with the enum keyword. Okay, this keyword enum is reserved in Visual C# for enumerated type. Okay, followed by the name of the type, followed by a list of identifiers inside the curly braces. Inside the curly braces. So this is one example. Okay, this is one example. So for this line of statement, it will start with the keyword enum. And the second one is the name of the enumerated type. Okay, the name of it inside the curly braces. So it is the what? It is a list of identifiers. We have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Okay, we have 7 different days. So inside the brace, okay, so each identifier is an enumerator. Enumerators are constants that represent integer values. For example, the value of day.Sunday is 0. Day.Monday is 1. Okay, you see here, day.Sunday it is 0. Day.Monday it is 1. Okay, it is 1. So an enumerator a declaration can appear outside the application's namespace, inside the application's namespace, or inside a class. Okay, it is quite flexible. So once you have created an enumerated data type, you can declare a variable of that type. For example, we have day, right? Day has been declared as an enumerated data type for Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So we have name of the enumerated type. And the workday is the name of the variable, workday. So to assign day.Monday to workday a variable, we can do workday equals day.Monday, day.Monday. Enumerators and enum variables also support the toString method. Here we do day.Monday.toString, you will see Monday. You will see Monday. So enumerators, here you see that we have mentioned enumerators are constants that represent integer values. The value of day.Sunday is 0, day.Monday is 1. But although enumerators are integers, but you cannot directly assign it to a int variable. Okay, it is different from a straight int number. Okay, even though they are integers, so you have to use a cast operator, which is you use int inside a pair of parentheses before, right? day.Friday. Okay, day.Friday. You will see that day.Friday, it is 1, 2, 3, 4, 5, the sixth element, so it equals 5. Okay, 8 equals 5. So an enum variable can be converted to int. In this case, you do workday equals Monday. So it is the Monday element, even though they are constant, but you cannot use it as a int number directly. You need to use a cast operator, which is a pair of parentheses with int with the keyword int inside it. Okay, inside it. So you can specify default values to enumerators. So in the previous one, right, we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So by default, Sunday is 0, right? Monday 1, Tuesday 2, Wednesday 3, Thursday 4, Friday 5, Saturday 6. Okay. But you can also specify default values to enumerators. For example, we have enum month days, right? January 31, February 28, March 31, April 30, May 31, June 30, July 31, August 31, September 30, October 31, November 30, December 31. Basically, we want the number of days in each month, okay? So in this case, if we still declare a monthly object, a day equals monthly dot January, okay, it will not equal to 0. Okay, it is not default setup is 0, 1, 2, 3, 4, 5, 6, 7. Instead, in this declaration, we have declared January equals 31. Okay, it will equal to 31. Okay, it means we can ignore the setup of these values. If these values are ignored, so it will be set to 0, 1, 2, 3, 4, 5 by default. Okay. So if you have some specific requirement for these values, so you can set up in the declaration of the enumerated data type. Okay, enumerated type. Okay. So here is one example. Assume the enumerated type day has been created. So we have a Sunday, Monday, Tuesday, until Saturday. What is the value of number of days after the following statements are executed, right? We first declare, right, object, then we try to see that workday is a day object, okay, object. Then we try to use a cast operator int to transform the workday to a number, int number. So Tuesday is the third element, right? It is the third element in the definition here. So the third element, and we have not set up the corresponding value for each element. So it will use 0, 1, 2, 3, 4, 5, 6, 6, right? So the third element will have number 2. So we'll see. So it equals 2, okay? So num of days, that int variable will equal to 2. Okay, will equal to 2. Okay. So another concept which we will learn in this semester is dictionaries. With dictionaries, so a dictionary is an object that stores a collection of data. Each element has two parts: a key and a value. Each key is associated with a specific value, and the key is used to locate that value. These are called key-value pairs. You see that here we have two things. The first one is a key. The second one is a value. Okay, the key will be something like the ID in a database. Okay, when you want to search something, for example, when you want to find the record of a customer, right? The first thing in your mind will be what? Will be the customer ID in the database, okay? The key will serve as an ID of the value, okay? So basically, we have key-value pairs, So the dictionary class, the .NET framework, provides a dictionary class that is used to implement a dictionary container. So general format declare a dictionary object is we use dictionary. Okay, that is built-in in Visual C# already. So we have two things to set up. First one is key type. Okay. Second one is value type. Okay. Then we have the dname is the name of the dictionary object. Okay. Then we follow new keyword. Dictionary still have keyword value type. We have a pair of parentheses followed by a semicolon. Okay. Here you need to set up three things. First one is key type. Okay, key type is the data type of each element's key. The second element is value type. Value type is the data type of each element's value. The third element is dname. Dname is the name of the dictionary. For all the other parts, they are fixed. Okay, they are fixed. Okay. For us, for a user, for a programmer, so you only need to set up keyword, key type, value type, and dname, the three different parameters. Okay. So how to initialize a dictionary? Here are some example code. Okay, we have dictionary. That part is fixed. So we have int and string. So what is the first element? First element is a key. Basically, we want to see what is the ID, the type of the ID, okay? That is the first element. In this example, we know that the ID will be in int format. It means for a customer, so we will have a int number to represent its identity information, okay? Identity information. The second element is string. So what is a string? String is a value type. Basically, it means, so for that record, what will be the value? The value will be a string. Okay, will be a string. Okay, we have in this pair of curly braces, we have 4 records. Okay, 4 records. You'll see that here first we have 101, 101, which is the int number. Okay, it means the first employee, its ID is 101. String is its name. Its name is a string, so we use double quote. So it is Chris Jones. Okay. For the second employee, its ID is int 102, and string and is a name. Name is Jessica Smith. Okay. We also use double quote for string. The third record is 103, which is the int number ID information. So the string is Amanda Stevens. Okay, which is the name of the third element. Of the employee 103. So for employee 104, the ID 104, the name is Will Osborne. Okay, Will Osborne, and it is his name. You see here, we use dictionary, and for each record, we have 2 different components. The first one is the ID. In this case, it's a int number. The second one is the name. In this case, it is a string variable. Okay, we have 2 different elements for each record in the dictionary. So adding an element to a dictionary. So here is the format. First, we have dictionary name, and we have a key. Okay, key is the element we want to add. So equals a value. Okay. So here, for example, we have declared employee, employee dictionary. So in this case, we have not declared any elements like this one. Okay, we just declare empty. Okay, we declared it. So, and we can add employees, which is the name of the dictionary. We do 105. 105 will be the key. Okay, it means we have, so we want to add a record. The first element of the record is 105. Okay. And the value of the element will be, the value of this employee or of this element will be Beth Young, and it is a string, okay? Also, we can do employee, and we do 106. 106, another key. It means that we would like to add another employee to the dictionary, okay, to the dictionary. And its value, the name is Jake Brown, and it's a string format, okay? So we can use the add method. Okay, we can also use the add method. We can do declare a dictionary first. Okay, then we do employee.add. Add. We have two things for each element. First component is the ID. Second component is the name of the employee, right? We have add 105 Beth Young, add 106 Jake Brown. Okay, so you can do either one to add elements, to a dictionary. So in other words, so dictionary type is quite flexible, right? You can declare the dictionary with some initial values, with some initial elements, right? When you have new elements for the dictionary, you can add those new elements to an existing dictionary. Okay, it is quite flexible. Okay. So how to retrieve values from a dictionary? So the general format is we have the name of the dictionary with a key. Okay, with a key. For example, to display the elements of the employee, right? The employee dictionary shown on the previous slide. Okay, so we can do this. So for key is 101, key is less than 105, key plus plus. So here, because in this example, key is int. Okay, key is int. So we can do this. Okay, we can do the for loop by using the given condition. Key is a int variable, right? So for each key number, we can do employees list box, list box dot item dot add. We want to add what? You can see we add employees key. Basically, we are going to add the values to the list. Okay, intuitively, we are using the key information to retrieve the value of each element in the dictionary, then add, in this case, add a string, the name string, to the employee list box, okay? So we can also use the remove method to remove elements from a dictionary. So for example, here, employee.remove, we do 105. Here, so inside this pair of parentheses, we also need a key. Okay, we also need a key. In this case, key is 105. Okay, so this will remove the value which has a key equals 105. And in this couple of slides, we know that key 105 is Beth Young. Okay, so Beth Young will be removed from the dictionary. Okay, from the dictionary. So how to retrieve values with the try get value method. The general format is dictionary name dot try get value. Okay, that is another way to retrieve values. Try get values. Key is the key you want to retrieve from the dictionary. Output to some target variables. Okay, the method returns true if the element is found. Sometimes you have to have the key in your dictionary. Sometimes the key does not exist in the dictionary. Okay, if this method is executed successfully, the method returns true. Otherwise, it will return false. Okay, here is one example. So we do if employee try get values, we get 104 out to name. Okay, we want to retrieve the element with key information, key equals 104. If the retrieving is successful, the value of ID 104 will be assigned to variable name, right? So we will display the message, the name value in a message box, message. If the retrieving is not successful, we go to else. So we will see the message, employee 104 was not found. Okay, was not found. Okay. This is another way how to retrieve values from a dictionary. So we can also have some other two useful properties, the count and element at properties. Okay, element at properties. So dictionary objects have a count property that is set to the number of elements in the dictionary. Okay, in the dictionary, the count property is used with the element add property to iterate over elements in a dictionary using a for loop or in a for loop. You may be wondering why we need it, because we have learned how to retrieve all the elements from a dictionary right here, right? You see, I have int key equals 101, key is less than 105, key plus plus. Why we need that? Another method. It is because in this specific example, so key is a int variable, right? Also, key, you can see that for different ID, key information of different elements, employees, they are consecutive, right? We have 101, 102, 103, 104, we add 105, 106. They are consecutive, right? This is why we can do this. We start from 101 and we try to increase key by 1 in each iteration. We can enumerate all the elements in the dictionary, but sometimes, right? Sometimes the ID information is not consecutive. For example, I have a list of all the students, right, in the class, in my class, ISM 3232, and I want to enumerate the record of all the students. I cannot do this because even though you have a U number at first, your U number are not consecutive. So they're unique, but they are not consecutive. But I still want to use the U number to retrieve the record of each student. What can I do? Okay, in this case, what can I do? So we can do the count. We can use count and element properties. Okay, this is a format. Okay. So at first, we use employee.count property. So that property will give us how many employees are there. In other words, if I try to collect, I have declared all the students as a dictionary. If I use the count property, so it can tell me, right, how many students are there. It's a number. Then we can have a for loop, right? We can have a for loop, okay? So the second thing is, so we do element equals employee dot element at I. So what is that? So it is, let me explain this, okay? So it is this. Okay, it is. For example, let me make some. Okay, it is. I have, this is one UID for a first student, and its name is John Smith, right? And we have nothing U. Okay. Second one, and I have now three students. Okay, and its name is, okay. I have three different names. I have three names of students, right? So in this case, right, so you can see that UID, they are not consecutive. Okay. So for each unique entry in the dictionary, there is a value for the name of the student. Okay. So in the slide, we have what? We use element add. What is that? It is, so in C#, right? C# try to label, right, each element with. First guy will have an implicit, right, ID as 0. Second guy, implicit ID as 1. Third guy, implicit ID as 2. Okay, this is implicit, right, index. Okay, implicit index. Implicit index. So when we use this kind of implicit index, you see that element at number 0 will be the first element, right? You see, by using count property, we know that there are 3 different people, right, in the list. So element at position number 0 will be the first guy, John Smith, right? So we'll add So element dot key plus dot plus and the value, right? We will add key plus value to the list. Okay, basically we'll add U number plus a name to the list. So second thing, and in the second loop, I equals 1, element and 1 will be the second element, right? We will add element dot key plus element dot value. We add U number plus its name. We in the third iteration we will have implicit index. Okay, index. Number 2, which is the third element in the dictionary. So we will add the U number U3444567 plus Jessica Mary, okay, plus this to the list, okay. You see that here. So previously, so we used try to get value by referring to its key information. Here we try to treat the dictionary as an array, okay. As an array, we use its count property, okay, and we use the element add property to retrieve the element in position number 0, element in position number 1, element in position number 2. Okay, basically it is a different way to enumerate all the elements, okay, in a dictionary. Okay. So this is the two properties of a dictionary. Okay, I think this is pretty much chapter 9, which is a short chapter. Okay, so we finished the chapter, and we learned some concepts in this chapter. Okay, so hopefully you can learn something from this chapter. So also there are more chapters remaining in the textbook, which we do not have opportunity to cover. Okay, we have already covered 10 chapters, which is already a lot. Okay, so for these chapters, if you really want to learn more for computer programming, you can learn it by yourself because, to be honest, the textbook is very clear. It provides a lot of details, examples, and a lot of explanations. Okay, you can learn it by yourself. Okay, so I encourage you to learn more from the textbook because it can help you build your coding background. Okay, so if you are satisfied with the 10 chapters you have learned, it's okay because I believe the 10 chapters have covered a lot of important basic concepts for computer programming. In the future, for example, in next semester, right, if you want to take the course Python for data analytics, so a lot of concepts will be almost the same, okay, almost the same for computer programming. So with a solid computer programming background, you will focus on data analytics algorithms, okay, data analytics algorithms. So this is chapter 9.